All right, so what this video is going to be looking at is isomers. So I need you to go back a couple pages to where we talked about the alkanes. This is kind of how I have the notes set up. So underneath the halogens, you will see where it says isomers. So if you would please copy down the definition. So an isomer has the same molecular formula, but a different structural formula. That is what an isomer is. So I'm going to explain it talking about alkenes first, and then I'm going to go to alkenes and maybe alkynes. We'll see timing-wise. So if I take C5H12 and I put it in what we call a straight chain format, okay, I would call this molecule pentane, okay? But can I rearrange these carbons to have the same number of carbons and hydrogens, but have a different structure, okay? So if I were to take 4 carbons instead, take one of the carbons off the end and put it as a branch, okay? That's still gonna have the same number of hydrogens, and you could count the hydrogens to see that you have the same number, but it's going to have a different name. And if you have the same formula, but a different name, that has to mean it's a different isomer. So this is going to be 4 is the longest chain, so this is going to end in butane, okay? And I have a methyl group off of the second carbon, so this is going to be called 2-methylbutane, 2-methylbutane. So is there another structure I could draw? Well, I can't really move that carbon to this carbon here because I would start numbering it on the right-hand side, and so that would be exactly the same. And how you sometimes draw these isomers is you may have to draw it and see what the name happens to be to see if it is truly a different isomer. So the only other one you could possibly do here is like a plus sign. So you have 3 carbons and 2 branches off of that middle carbon. So this is going to end in propane, okay? And I essentially have a methyl and a methyl. It doesn't matter which way you do it, but it's 2,2-dimethyl propane, okay? So these are all isomers of each other, but their structures are very, very different, okay? So now I need you to go to the page after alkenes, where we're talking about the double bonds, and go to the page where it says cis and trans, cis and trans. So this is the one we're going to spend the most time on because this is the most complicated of the ones that you're going to see. So I'm going to draw a double bonded molecule a particular way, and you will see why I'm doing it this way. So I'm going to draw 2 molecules. So I have 2 carbons, okay, with a double bond between. I have a chlorine on each one of them. These chlorines are here, the chlorine is here, the chlorine is here. So because we have a double bond, in terms of its structure, the chlorines are going to be either on what we call the same side, so this is what we call the same side of that double bond, while this is going to be on opposite side. So in terms of the structure, a lot of organic chemistry has to do with that double bond and getting rid of that double bond or adding to, taking things away. So if you had the same thing on the same side, you're going to have an easier time of taking away these chlorines than you have it on the opposite side. So we have to have a different naming system for both of these because otherwise they're going to be named the same thing. So they're both going to end in ethene, because you have only 2 carbons, okay? And I have a 1,2-dichloro, okay? 1,2-dichloro. Because, again, I have a chlorine off of the first and second. So I have no other way to distinguish this. So what we have is a system called cis and trans, okay? Cis means same, trans means opposite. So what I do is, in front of the name, I'm going to put cis for the one where the chlorine is on the same side or the substitution is on the same side, and trans in front of the one that is on the opposite side. So let me draw another one and see if we can name this one. And I sometimes draw it in a particular way so that you could see I'm talking about the double bond itself and what is going on there. So see if you could draw this molecule here. All right, so here are my bromines. Okay, here are my bromines. But when I draw it this way, you first need to consider what is the longest number of carbons, okay, in a row. So I can't just look at the double bond and just say everything is ethene. So I have to look at the fact that I actually have 4 carbons here that are all attached. I'm just draw it in a particular way. So I have to name this butene at the end, okay, because I'm talking about 4 carbons, 1, 2, 3, 4. Now, where do you start numbering? It doesn't really matter because that double bond happens to be between the second and the third, so that's kind of irrelevant, but you would still need to label them. So I have to put a 2-butene to say it's between the second and the third carbons. Now the second and the third carbons are where the bromines are. So this is where I'm going to put a 2,3 dibromo in front of the 2-butene. But I'm still not done. The bromines are on the same side as each other. So am I going to put cis or trans? I'm going to put cis. Okay. If the bromine had to be drawn up here, then you would call it a trans. So this works really well for if it's the same, what we call substitution across that double bond, okay, either on the same side or on different sides. But we have another naming convention that is more useful for what we call more options that you might see in organic chemistry. So again, I'm going to keep it relatively simple. So again, I'm going to keep C double bond in the middle, and fluorine and chlorine on this one, bromine and iodine on this one. So if you have substitutions that are different, you're going to have to use what we call the EZ convention for this naming system. So E stands for Ingingen. It is a little bit of German. You don't need to know that, but that means opposite. And Z stands for Zusammen, which means same. So, unfortunately, this is a rule that they have. So what you're going to do is kind of cut the molecule in half across that double bond, okay? And what you're going to be comparing is fluorine to chlorine and bromine to iodine, okay? And you can't do it alphabetically. This is the one weird thing about organic chemistry. You have to go to your periodic tables and you have to look at what you call its masses. So fluorine is 19, chlorine is 35, bromine is 79.5 to 79.9 and 126.9. So again, I will write those numbers just so we have them in our notes. So if you could look them up later. So what you do is you use mass to determine which side are the bigger things, because the mass is going to be the number of electrons, number of energy levels. So it's going to be a bigger thing on that double bond. So chlorine is the bigger of the two, comparing fluorine to chlorine. And then bromine compared to iodine, iodine is the bigger one. So if the bigger groups are on the same side, you're going to put a Z in front of it. If the bigger groups are on opposite side, you're going to put an E in front of it. So this one, again, is going to end in ethene, okay? And naming system. Well, bromo is going to come first, so that's going to be the first carbon. That's going to be the first carbon. So I'm going to start over here. I'm going to say 1 bromo. Then I'm going to have the second carbon is the chloro. That comes next in the alphabet. Then it is 2 fluoro. Then it is 1 ido, ethene, okay? And then you put a Z in front of it like you did a cis or a trans to say that the bigger groups are on the same side. The bigger groups are on the same side. All right, so let's do another example. So I'm going to pause the video, see if you can name it. So the name is Z3-bromo-4-chloro-3-heptene, okay? Again, the longest chain is going to be all of these carbons, okay? So even if I draw it funny, these are still the longest chain of 7, okay? And number them so that you know that it's not a branch. And then this is the goofy part. Again, you're comparing chlorine to all of these carbons with the hydrogens. So chlorine is 35.5, but the carbons are all 12, so 12 times 3 is 36, plus those hydrogens about 43, so that's the bigger group. And then over here, I have 2 carbons, that's 24 plus 5 is 29. Bromine is, of course, a much bigger, so that is why it's called Z, okay? So that is probably the most complicated of the isomers that you're gonna see. And one last thing, if you go to the alkenes page, just know that there is no cis or trans E or Z for your triple bond. And that is because you can't have anything on those carbons. But do realize that you can move where that triple bond is. So you still can have an isomer. You're going to have different names because it's going to be a 2 and this is going to be a 1. But you cannot have a cis or a trans or E or Z for a triple bond. So it's not going to be possible